Hey guys, in this video I'll be going over rate of effusion and I'll be doing a couple practice problems with it, so let's get started. So what is effusion and diffusion? Diffusion is a spontaneous spreading of one substance through another, and effusion is when gas particles escape from a container through a tiny opening. Keeping this in mind, we will go to Graham's Law of Diffusion, which is the main equation that you'll be using in all the practice problems we'll be doing and all problems dealing with diffusion, essentially. It is R1 over R2 equals the square root of molar mass of 2 over molar mass of 1. So yeah, we see the inverse relationship of 1 down here and molar mass of 1 down here. So always remember the inverse relationship, and you can be able to memorize this equation fairly easily. Some things to keep in mind when you work these problems is, again, remember that lighter gases effuse faster than heavier gases. And this is the inverse relationship. And I'm just going to reiterate this because this is pretty important. And something that just help you visualize it is that diffusion works the same as effusion. So just keep that in mind. And then lastly, this is most likely the most important. Rate is not the same as time, and rate is always delta x, which is delta something, over delta time. So what I mean by this is you say miles per hour, which is a rate. You do not say hours per mile. So just time is not the same as rate. So whenever the problem gives you time, do not just plug it in and go and chug and just calculate. You gotta get to do some extra steps. So for our first example problem that we'll be doing a simple basic plug and chug question. So to start off, you want to write your equation, and what'll help you is to write down all your variables so you won't get mixed up. And also another tip is to go ahead and make the unknown of what you're finding in the numerator. And since you were looking for the rate of O2, you're looking for an R value of this. So just go ahead and make the top one your unknown. So go ahead and write out all your variables. R1 would be your unknown of oxygen gas rate. R2, which is 4.35, and that's the nitrogen gas rate. M2, and this is the nitrogen gas molar mass. The two R2 rates. Okay, and then you just look out the periodic table to find the molar masses. Remember, it's diatomic, so you have to add them up. And for oxygen gas, M1, again, remember diatomic, so that will equal 32.00 grams per mole. So now that you have all this, you can go ahead and plug into your equation, R1 being your unknown, 4.35, and use your calculator, and you will get the rate of oxygen to be 4.07, excuse me, moles per liter second. So this is a fairly easy problem, and this is pretty basic to start with, and just remember the equation, the inverse relationship, and always make your unknown in the numerator. It'll just help you in the long run. Just make things simpler overall. Alright, so for the problem 2, we'll be doing one that is dealing with time rather than rate. So we're going to have to be doing things a little bit differently than we did for the previous problem. So first, you want to write your equation again. Okay, and remember that rate is not time, and they're giving you time here. And remember, rate is equal to delta x over delta t, and that time is in the denominator. So you can't simply just take this 4.73 value and just plug it straight into this rate value. It won't work out. And alright, so you're looking for the unknown, the molar mass of the unknown gas, and go ahead and make this your unknown, because it'll just make things simpler in the long run. And you know you're given molar mass, which is 28.02, and the 28.02 is for nitrogen gas. So nitrogen gas applies to that 3.75 minutes, and so you'll have your R1 will technically be, your R1 rate will be 1 over 3.75 minutes, and you have to keep it 1 over time, because that's how a rate is. So once that'll be your R1, because it'll correspond to your molar mass 1 of the nitrogen gas, and your R2 will be 4.73, and this is for the unknown. So now you will write out your equation with their known variables. 3.75 divided by 1 over. Okay, so from here, mathematically, these will essentially flip spots. So you will end up having 4.75 up on the numerator and 3.75 in the denominator. This is the different step that you must take for time, and that it'll just essentially be inverse from rate. So once you're at this part, you just plug into your calculator, and your M2 will end up being 45 grams per mole. And that's basically it. I hope this video helped you guys, and thanks for watching.